Hey class, I'm Mr. Thornton. You've got 5 days until May and I'm going to help you succeed in your GCSE. This lesson, interpreting graphs in exams. Obviously graphs show up in maths and they also show up in science. You may see them in other subjects as well. Once again, geography could be a good contender for something where you may have to interpret a graph. And they're pretty straightforward. As with tables that I discussed yesterday, graphs are something where you just have to describe what they're showing you. You don't need to know any additional information, you just need to be able to look at it and say, well, this graph tells me this. So these ought to be fairly easy marks, but again, it's something where, and I completely understand this, it's something where sometimes people just sort of have a blank and forget what to do. They're pretty straightforward though. If anything, they're more straightforward than tables. So let's have a look at them. And we're going to start with the simplest type of graph, and that's this, the pie chart. This crops up quite a lot. And the key thing to remember about a pie chart is that all the segments of a pie chart add up to 100%. Typically, the way a pie chart is presented is that you have to find out what percentage a particular section is. And it's really simple. All you do is add up what percentage all the other ones are and just take that total away from 100%, and that will give you whatever's left, which is the remaining slice of your pie in this case. You may need to do a little bit of interpretation. In particular, you might need to convert back and forth between some common fractions and percentages. So remember, 1/5 is 20%. That is the same as working out 1/5 of 100, of course. 1/4 is the same as 1/4 of 100%. So that's 25%. 1/2 is 50%, and so on. You've probably covered these a lot in maths, but if in doubt, just work out the fraction of 100% and that will convert the fraction for you every time. The other thing you might need to do with this sort of graph is make some sort of comment on it. Is a particular section a really big section or a really small section? Is it more than half of everything and all the other sections add up to less than half of everything? You need to make some sort of commentary, possibly, on what this means. Now, all you're demonstrating there is that you can look at this and go, well, that particular thing, that's a really big section of this. That's about the level which you need to go into. No one's looking for hugely detailed analyses, they're just looking for you to have an appreciation that a bigger section means a much more important bit than all the other stuff. You may also have to work with a line graph. If you see a graph like this, where there's points on there, on a piece of graph paper in the exam, and those points haven't been joined up, then 9 times out of 10, somewhere they will be asking you to join those points up. They will be asking you to put a line on that graph. You would not believe the number of mock exams I've marked where people had all the points just waiting for them to join them all up on that graph and then didn't do it. Somehow managed to miss the question. If you've got a half-finished graph, assume that they're going to want you to finish it. Even if you can't see where it says that you should finish this graph, there's nothing stopping you taking your ruler out and joining these points up. Now that's if the points are in a straight line. If they're not in a straight line, it's generally going to be pretty obvious. And so if it's not a straight line, then you just draw one smooth line through it. So take out your pencil and just draw through those points. And I do recommend that you use pencil just in case you make an error, and then you'll be able to rub it out and start over. One thing they do like to get you to do on this sort of graph is they'll leave out a point and ask you to plot it. They might even ask you to do a calculation to work out what that point's going to be and then plot it. Now, a little tip, if you can't figure out what that point should be, if you can't do the calculation first, then just put any number down and you can get an error carried forward mark. So come up with anything vaguely sensible, write it in there for the previous bit. You're not going to get the mark there, but when it comes to the question of did you plot that point correctly, you can still get the marks. In fact, that's true for anything where you need a previous answer to be able to answer the next question. If you're not sure what that previous answer is, you don't know how to work it out, then put any number down and use that in your next calculation and you can get the error carried forward mark. One thing which they do like to do is be a little bit sneaky with the scales. Normally the horizontal axis is fairly straightforward because there are only specific values which you can plot, but the vertical axis is the one where they can really get sneaky with you. On one of last summer's papers, the vertical axis looked like this. Candidates had to plot a point at a vertical level of 64. Now look at that scale in between 60 and 80. There are 10 small squares in between 60 and 80. And what an awful lot of candidates did was they found 60, they counted 4 small squares up and they said that's 64 and plotted their point there. That was wrong. Remember, those 10 small squares, that's dividing things up evenly. Between 60 and 80, so that is 5 squares up from 60, it's got to be the number which is in between 60 and 80, 70. So these candidates were actually plotting their mark at a level of 68, not at a level of 64. They were 2 squares too high. And that's because there's 20 marks in between 60 and 80, but there are only 10 squares, so each square counts for 2. This is what threw a lot of people. So watch out for scales like this. Think. Take your time, ask yourself how much is each little square worth. Look at what the scale goes up in this case 20s, and then look at how many squares are between each one of those 20s. Then do the amount it goes up in divided by those squares. So in this case it goes up in 20s, and each 20 counts for 10 squares, so you just do 20 divided by 10. In fact, most of the time you're going to do that number divided by 10 because most graph paper, as you know, has 10 small squares between these bolder lines. That was something which did throw a few people, so do be careful of that. And when you plot the points on these sorts of graphs, you also need to be careful because they generally don't allow you to be very far away from the actual mark. So take care over this. Try and get it right on where it should be. Now, once you've got your graph, what next? Well, usually if you see a graph like this, and it doesn't always happen, but it almost always does, usually what you're going to need to do is figure out one value from another value. So normally what they'll give you is a value on one of the scales, on one of the axes, and they'll want you to convert that to a value on one of the other scales on the other axis. It's a little bit easier if I show you though. That's not the clearest explanation. So let's say, for example, on this graph, I knew that my input here, my independent variable, I knew that was going to have a value of 5. What I would then need to do was draw a vertical line up from that 5 until it hits the line of my graph. And I then draw a line across from there and read the new value off the vertical scale. You've done this before. I know you've seen this before. If they ask you what will the value of this be, if the value of this other thing is this, then that's all they're getting at. They just want you to draw those lines on the graph, and do draw them on the graph in your exam paper. It works the other way around as well. If you've been given a value on the vertical axis and they want something from the horizontal axis, then you just draw a line across from that vertical axis until you hit the line, and then down to the horizontal axis. You're always going either up and across or back across and down. And it's the same process each time. It doesn't matter which axis they give you the numbers from. You just do that until you hit the line of your graph and then change direction, read the value off the next axis that you hit. It's that simple. Lastly, bar graphs and bar charts, which can go from being really easy to understand to actually being quite tricky to understand. So let's take them one step at a time. Firstly, you might get really simple ones like this. This is not much more complex really than our pie chart. The taller the bar is, the more that particular value represents. You need to be able to read these values off the vertical scale though. And again, that vertical scale might be a little bit sneaky. They might go up in 20s or they might go up in 50s for every 10, and you're going to have to take a little bit of care to read that. Again, ask yourself what each small square means. What does each small division on that scale mean? Think about it for a second before you do anything else, and you should be able to work it out without too much difficulty. You're probably just again going to be dividing 20 by 10 or 50 by 10 to get the value of each small mark. They might also give you some information to plot on here. Again, this is just a test of whether or not you can read that scale. They might take it a step further, as with the line graph, and ask you to work out an answer and then plot that on the graph. Again, if you don't know how to work it out, put any number down and then plot that, and you will get an error carried forward mark. The trickiest one of these I've ever seen was on a paper last year again, and it was a bar chart which looked like this. You can see there's positive and negative bars there. This was one for calculating how much carbon dioxide is released into the atmosphere. You've got negative values here, and what caught an awful lot of people out was that although you add all these positive values up, and an awful lot of people managed to work out the size of those bars just fine and add them all up, what they didn't do was subtract the negative values. But this is just like in maths. So if this first one has a height of 1, and the next one has a height of 3, and the next one has a height of 5, then you add those up. 1 plus 3 plus 5 gives you 9. These two down the bottom here, though, are going to be subtracted from that. So if this one has a depth of 2, we can represent that with the number -2. And if this next one has a depth of 3, we can represent that with the number -3. So altogether, they come to -5. So your calculation is going to be the +9 from the top minus the 5 from the bottom. 9 minus 5 gives you 4. That's what threw a lot of people. And that made it really difficult for people to then make sense of the next questions because they misinterpreted what the graph was showing. So try and stay aware of that. This is the most complicated one of these I've ever seen. They do tend to be quite often a lot simpler than this, but it is a little bit sneaky. Look out for those negative numbers on one of these as well, because there's no reason why they couldn't show this to you again this year. I hope that video really helped you. If it did, it really helps my channel when you like, subscribe and share these videos. Let people know I'm going to succeed in my GCSE. All the links and info for this video are in the description, and please let me know what you thought in the comments or on Twitter at Mr. Thornton UK, or use the hashtag #SucceedInMyGCSE. There are loads more GCSE science videos on my channel too. Here's another one which YouTube thinks you might find useful. You can click my picture just here to subscribe, click down there to check how well you understood with the SnapQuiz website and app, and you can click just here to get my revision guides. Good luck in your GCSEs everyone, and thanks very much for watching.